sheer power of a modern-day computer staggers the mind. This power has never been fully utilized in asphalt production until now. What does it mean to fully utilize this power? It means control, automatically activating each part of an asphalt plant in the right sequence and at the right time. It means data, storing a variety of mixed formulas, information about raw materials, and about customers. It means total plant simulation for training and troubleshooting. It means automatically diagnosing and pinpointing many problems that might arise. And it means keeping a complete record of everything that happens at the plant, so this data can be recalled and analyzed at any time. Impulse by CMI Corporation is the first and only control system that can do all this in a hot mix asphalt plant. And it can do much more. Impulse is an integrated system of both hardware and software. The two major pieces of hardware are the computer, or central processing unit, and the programmable controller. The programmable controller is the interface between the computer and the asphalt plant. It actually operates the plant by switching motors on and off and reading sensors and scales. It relays this information to the computer and relays the computer's reaction back to the plant. And each message is transposed into a signal that is acceptable to the other unit. The computer has 640K of RAM memory and hard drive options up to 322 megabyte. The operator works with a color monitor, keyboard, and touchpad. The monitor shows a layout of the entire plant, and every piece is color-coded. When a unit is not active, it appears in red. When it is operating, the color changes to yellow. So a glance at the screen tells exactly which components are operating. All temperatures and flow rates are listed beside the appropriate units. Silos graphically show the level of materials as well as tonnage. The program is menu-driven. The operator selects a function, then follows on-screen step-by-step instructions. For example, startup procedures guide the operator through each step of starting motors in their proper sequence. As each step is completed, new instructions appear. Incorporated into the startup procedure is a peak power feature. When a big motor is started, the system interlocks prevent starting a second big motor until the first one has come up to speed. This greatly reduces peak power demands. Other step-by-step procedures cover plant shutdown and calibration. The plant operator no longer has to remember all of the formulas necessary to calibrate scales or meters. For example, on the belt scale, he enters the beginning span setting and the tare weight of the truck being used for the test. Then, after running material across the belt scale, he enters the truck's gross weight. The system automatically calculates the net weight, what the percent of error is, and the new span pot setting. At the end of the calibration test, the operator can get a printout so he has a permanent record of when the plant was calibrated. Several features were incorporated to minimize the amount of material waste, normally associated with drum mix production. The primary features are in the mix design itself. Impulse will store up to 20 mix designs. Each formula contains a percentage of each material and a programmable start-stop time for each material. This gives complete control over the staging of materials for each mix. Additional mix storage capacity is available as an option. PID technology is used to control each material that goes into the process. PID is a sophisticated control technology that offers the ultimate in accuracy and system reliability. Operator error is virtually eliminated and efficiency is drastically increased. Also, to eliminate waste, the asphalt line is automatically cleaned between mixes. This means that the pump is reversed and the line is cleared so that the asphalt ejection time starts from the same point on every run. Impulse automatically controls cold feed material flow in one of two ways, either volumetrically, based on the speed of the feeders versus a final belt scale, or weighing each material separately by placing a belt scale between each aggregate bin. Materials are then controlled according to the mix formula entered and the individual moisture contents of each aggregate. A feature that is very useful in commercial applications is the production stack. The operator enters the parameters needed for each run in the production stack. He enters the mix number, how many tons per hour, total tons he wants to produce, which silo he wants the mix to go into, and the desired temperature. 3 production runs can be entered, back to back. When the start control is selected, Impulse automatically begins production of the first mix in the stack. The mix is produced at the right temperature, placed in the right silo, and when the proper number of tons has been made, it automatically switches to the second mix. The first mix is sequentially shut down, and the second mix is sequentially started behind it. The traverse conveyor is automatically switched from one silo to another at the proper time. The demand mode allows an operator to interrupt the active mix for a special load. He enters the mix specifications and designates 9 as the silo number. Silo number 9 refers to the gate in the bottom of the drag conveyor. When the demand mix is entered, Impulse automatically shuts down the active mix, starts up the demand mix, and opens the drag gate at the proper time. When the tonnage called for has been made, it then goes back to the active mix right where it left off. Numerous alarms are monitored in the background. No matter what screen is displayed, when an alarm condition is detected, several things will happen. 1, an audible alarm will sound from the control panel notifying the operator of an alarm condition. 2, a one-line message is displayed at the bottom of the screen identifying what the alarm condition is. 3, the alarm is logged on the personal computer's hard drive along with the time and date that it happened. And 4, the alarm message is printed out. Along with the alarm conditions, every operator command is recorded on the hard drive. Using this history of events, one can get a report showing the complete plant operation for any time period. Also recorded on the hard drive is every process variable. This means flow rates of all materials, set points, temperatures, and various pressures. This data can be recalled using the data logger feature, which is a historical data retrieval system. Through data logger, the operator can look back in time and find out the performance of any of these plant variables. The amount of history available is limited only by the available disk space. It is possible to store up to a year's worth of information. Several standard reports are included in the Impulse program, but it's very simple for the operator to create a special report based on any information he wants to see. He simply enters the time span and the variables he wants to look at. For example, let's look at what happened on the 7th of June, 1989, starting at 4 o'clock in the morning. Let's see a window 2 hours wide, ending at 6 a.m. The 3 variables we're going to plot on our graph are actual AC content of the mix produced and the high and low tolerance band of the asphalt content. Data logger will retrieve from the disk any information stored on the 7th of June during that time period and plot the performance of those 3 variables. As you can see, after the mix started up, the asphalt content came within specification. That mix was shut down. A second mix was started with a different set point. On the right side of this graph, the numbers 300 to 700 mean 3 to 7% asphalt content. The graph shown here on the screen can be printed out for a hard copy record of this performance. Imagination is the only limiting factor in creating data logger reports. All the variables are recorded so that a graph can be made based on any desired data for any time period. Other production reports can be produced on demand or at selected time intervals. These reports are called real-time production reports. They are basically a snapshot of plant operation at a moment in time. By touching the print control, an operator can generate a snapshot of the screen showing flow rates and all of the set points at that moment. The diagnostics feature is an important part of the Impulse system. Through diagnostics, the operator can locate any problem points in the plant that may be causing a malfunction. For example, if the pilot fails to light, the operator selects diagnostics and the computer looks at every component that affects the pilot. Then it reports the probable cause on the screen. In this case, there is no combustion air, so either the blower is off or the pressure switch has malfunctioned. The simulator mode is an important part of the diagnostics process. Each Impulse system can simulate plant operation without actually firing any motors or running mix. This is a very useful tool in diagnosing problems as well as training new operators.
What do I do if the belt doesn't start?
Well, what you'll have to do is you'll look at the screen, and right here, you notice it says the drum bypass. Okay, you have to turn this
Another
off.
diagnostic tool lists input-output devices in the programmable controller. This feature reduces operator time previously spent looking up schematic drawings to get wiring information. He can bring up individual screens and see exactly how the plant input-output rack is laid out. With the optional telephone modem, personnel at CMI can access any plant and see various screens just like the plant operator without interfering with production. It's a very quick way to get help directly from the factory in isolating malfunctions and finding solutions to them. Another beneficial element that Impulse provides is management-related. It's an online, real-time cost analysis of the mix in progress. Numbers in the center column represent the unit cost per ton of material, fuel, and power. This information is entered by the operator or plant management people. As mix is being produced, real-time numbers appear in the right column with the grand total cost associated with that mix. This total cost value is recorded on the hard drive along with other production data. The data logger feature that we looked at earlier can be used to create a historical graph showing the cost of a specific mix over a period of time. It's possible then to generate graphs to see if there's an optimum flow rate or production level to get the best cost of that mix. In the simulator mode, a quality control person can manipulate the percentages of a blend of aggregates, staying within specifications, yet picking the optimum combination to get the best cost per ton. Other options available with the Impulse program allow monitoring such elements as fuel consumption and motor loads. Impulse is a very broad-based constructed system. When sensors and new technology become available, it is very simple to implement those into the control system with the software necessary to display and provide information to management and operational people. Impulse was conceived and designed to improve asphalt blending operations. In many instances, CMI engineering and marketing staffs have anticipated changing needs in customers' requirements. At CMI, it's our goal to give the asphalt producer the most accurate, most reliable, and most cost-effective system available today or in the near future. And that system is Impulse.